Good morning, everyone. Thanks for joining us for our presentation today. Our topic is retrofitting grid-tied PV systems with ProHarvest, brought to you by AEE Solar. And we have OutBack here presenting for us today. Before we begin, we'll just go through a couple of quick details. If you are experiencing any technical difficulties, if you're not sure you're seeing the right screen or you can't hear me very well, you can notify me by typing in your question or concern in the questions box. And that'll be on the right-hand side of your screen in that control panel from GoToWebinar. We will have a Q&A session following the presentation, but you're welcome to submit your question at any point during the webinar, and we'll get to those as many as we can after the presentation. And for those questions, you can submit them through that questions box as well. So just send them over, and I'll keep them for the end of the webinar. And I just wanted to let you know that there will be a brief survey that will pop up in a new window once you exit the webinar. It's really quick, I think maybe 4 or 5 questions. And if you complete that survey, we'll send you a copy of these slides. So really worth your while. We just like to get your feedback on these. We know your time is valuable, and we like to make these presentations as worthwhile as possible for you. All right, it looks like we're all set and folks are rolling in, so we'll go ahead and get started. I'll introduce our presenter today. We have Joe Ross, OutBack Power's very own National Sales Manager for ProHarvest. So Joe, I'll let you take it away from here.
Okay, thank you very much. Good morning, everybody. My name is Joe Ross. I am with OutBack Power. If you look at this first slide, it's worth mentioning just for kind of get everybody up to date. ProHarvest was a brand that we've been selling through OutBack for the last several years. In December, OutBack's parent company Alpha was acquired by Enersys. I'm sure many of you are familiar with Enersys. They're a large battery company. So it's a really nice combination of inverter technology, control, and now we have a large battery company behind us. So you're going to be seeing some really interesting things out of OutBack. Many of you are familiar with OutBack. The legacy has been in residential systems, single phase off-grid type of systems. The company was founded by a bunch of engineers at a now defunct inverter manufacturer that decided to, at lunchtime, go back and solve the world's energy problems. So every time they were being looked for, they would say, "Where are those guys?" And they would be OutBack. So hence the name of the company. So what I'm going to talk about this morning, a couple things. We're just going to go through the product mix for ProHarvest, giving you an idea of what the systems look like. We're going to introduce our new 10K inverter, which we brought into the market this year. It is a California Rule 21 compliant, so it has the UL 1741 SA control architecture in it. So it is applicable for any NEC 2017 installations or California Rule 21 installations around the country. We do still support the legacy Gen 2 products, which have a slightly less nameplate on the AC side for the 480. Instead of 10K, it's an 8 kW. But we also have a 208 version of this inverter, which has a 5.75 AC nameplate. And we'll get into those details as we go along. So let's take a quick look here at the product mix. And of course, my presentation has just hung up on me. There we go. So as you can see, it's a really small part count. What we're going to be describing in this is the inverter, AC web. We have a splice box, which we'll go through the detail on. Communications gateway, which enables communications up to 200 inverters. And then for certain applications, we also sell a ballast kit for mounting. So if you're on a flat roof, you can actually, and you'll see examples of this, put the inverters right up underneath the panels themselves, use these, their panel cloth mounting kit feet, and it gives the ability to just set and forget the inverter. So really, it's, again, this is a 3-phase inverter, so it's designed for commercial applications. Ideally, designed for rooftop applications. Just a quick background on myself. I've been in the industry about 10 years, worked for a few central inverter companies, PV Powered, became Advanced Energy. I subsequently went to HighQ when Advanced Energy exited the solar space. So I've been working with this inverter since 2015. We've had a lot of success with it. The really nice thing is it's very flexible in terms of voltage range. As you can see, we can handle 600 volt and 1000 volt panel systems, both in the 480 and the 208 version. Each of the units themselves have their own separate, or each of the units themselves have two inputs for independent strings. So these strings are treated completely independently. You don't need to match power. You don't need to match string size. They each have their own separate MPPT ranges, which you can see listed there, for the 280, 200, 850, as well as the 480. The new 10 kW has a little bit broader range. We'll get into the details on that in the next slide. But again, so dual MPPT ranges, 2 settings per string, 2 strings per inverter on the DC side. Very good CEC efficiency. We could have rounded that up to 99, but decided to be honest and call it the 98.6. The inverter itself is a anodized aluminum housing on an anodized aluminum base. We use a single-sided board and no capacitors whatsoever in the inverter energy management. So it's real-time energy management through the circuitry on a single-sided board. Why that's important is because the majority of inverter failures you'll see in the capacitor banks. Standard string inverters use banks of oil flow capacitors. They're cycling them hundreds of times a second, over a number of years. Those will fail. Typically, you see failures in 8 to 10 years, and that's what we're seeing now in the field. So hence the retrofit solution that we're coming up with to replace those inverters. So again, no electrolytics, therefore we need no cooling system. It's all done through convection, airflow over the fins on the inverter, which you can see there. We need about 3 inches of airflow around to maintain adequate cooling, but these can handle up to, as you can see, 65 C or negative 40 Cs. So it's a very simple design, very low part count in the system, but also the board itself is designed to be integrated with each of its own internal systems. So there's no separate circuit for the ASCI, there's no separate circuit for the other systems. It's all incorporated into the single side board. One thing that we do in the manufacturing process, one of the final things which makes this NEMA 6, so these will operate underwater, is we extract all of the oxygen out of that chamber during the final phase of manufacturing, and we backfill with nitrogen. And the reason we do this is to eliminate any potential for oxidation on the board itself. So they're vacuum sealed. They're vacuum sealed for life. Therefore, there's zero maintenance on these. We do not send technicians out to fix inverters. This is treated as an RMA, and I can get into the details on that process, but essentially we ship you a new one, put the old one in the box, ship it back, and you're up and running. Everything is terminated, so you can see all of the wires are terminated on the DC side with MC4 type connectors. And on the AC side, we have a proprietary 5-wire communication whip, which we use for power line communication, which we'll talk about here in a sec. This is the one line for the system itself. So what we typically do is we'll take 3 inverters, as you can see on the right-hand side. Each has 2 independent strings. Again, don't need to match them. They don't even have to match voltage. You can put 1000 volt and 600 volt strings on each of those strings, and it would not impact the inverter. You would not degrade one of the sides. Anyway, so typically we take 3 inverters. We come off with our AC power line into our junction box or our splice box. We separate the phases, the ground and the neutral, and then we come back with one drop 10 or drop 12 back to the load panel. And that's where you actually power your, the gateway is directly at the, off the AC power line. The real important thing is, so it's a floating neutral, but we need to have a 480 grounded Y. That's critical to the system design. So grounded, 480 Y, and we're good to go. This is our spec sheet on the new 10 kW. It's a bit of a eye chart here. I apologize for the size of it, but I believe you guys got this information. So really the big difference is it's a slightly larger AC nameplate, 10 kW. It's a slightly larger footprint. We picked up a couple inches in each dimension. The top of it looks a bit different than our standard unit, where you can see the vents are more of a spiky, kind of like what you'd see to maybe clean the grass off your cleats. It has that kind of topography. But other than that, they operate identically to the point where it's using the same AC power line, it's using the same gateway. You can see everything is terminated same way. So these are drop-in replacements for the Gen 2 units if you need to go that direction. But really, this was designed for California Rule 21, UL 1741 SA compliance. So we're getting a lot of nice traction on this. We're in the process of finishing the installation of our first 1,000 units, so first 10 megawatts, which started back in May. Everything looks good so far. We've had one or two failures, but they were really, one was a catastrophic failure, and one was just an out-of-box failure. So those were replaced, and everything is looking really good and positive on the new 10 kW units. As I mentioned, the gateway is really the kind of heart and soul of the system. You can communicate up to 200 inverters on the gateway. Once you get the gateway up and running, as you bring inverters onto the system, it will automatically populate and create and populate with the serial number. So that's all done remotely, all done automatically. It's got a touchscreen on it, and it's not as sensitive as like your bank teller touchscreen. You need to press in out a little bit with your fingernail in order to get it moved to register. But that's by design, so that if somebody bumped into it, there wouldn't be an issue. But typically these are going to be in your control panel or in your load center next to it in a housing. I'm going to talk a little bit about the functionality of the gateway, but one thing I wanted to point out, if you look on the bottom right, the second photo up, you'll see the side shot of the unit. So it's got a memory card in it. So it's it holds up to 10 years worth of data. So in the event that you do lose communication to the gateway, it will still be registering the harvest data from the array, and then you just essentially export an AVI file, from that disk to capture the the energy. This is also the way that we communicate with third-party monitoring companies if you need revenue grade data. Ooh, somebody I can hear type in the background, but it's okay. So I just wanted to take you through a couple of the views that you get from the gateway. So this is the kiosk view. This is what your end user would see. Very simple, straightforward. You guys have all seen these. It shows production, week, months. The weather, the amount of greenhouse gas offsets. Just kind of nice stuff to have in the lobby of the building, so that when people come in, they can see what's going on the roof or on the lawn. The next view you're going to see is the dashboard view. So this is what you, as the installer would have access to. So what the gateway will do is it will go out and create its own IP. You then type in into that IP, and it takes you to our cloud, and then you can see the individual units, the overall system performance. And I'm going to take you through a couple other windows here where you can actually see individual daily production. That's the full array. And then you can actually isolate in on each individual inverter and determine, how it's performing. So including the gateway. So you see the gateway, the different string inverters, how they're performing, and then we'll also take you down to the individual inverter itself. So you get actual string level detail on what's happening with your system. Very good diagnostic tool as well. We talked a little bit about what happens when a unit fails. Really, the first thing that happens is you contact our tech services, provided you have connectivity, which is, again, very critical to the system setup, having internet connectivity. Our technicians can go in, take a look and see what the fault is. They can try doing a remote reset. 99% of the time that's going to work. If it's something else, if they see something in the system, they can give you a heads up. If it is an inverter issue, then, as I said, we ship you a new unit, take it out of the box, put the old one in, ship it back to us, connect these up, and you're up and running in about 5 minutes once the units arrive. So this is a little comparison. I'm sure you guys are all familiar with Chris Canfield, who's your sales rep. Chris put this together. This was a personal experience he had with a 6 kW versus the ProHarvest 8 kW. So, in terms of weight, the Fronius is significantly heavier than the about twice as heavy as the unit as our ProHarvest. There are limitations in terms of mounting the Fronius. It's got to be wall mounted. Our ProHarvest inverter is agnostic to mounting. You can mount it in direct sunlight. You can mount it upside down, sideways. It doesn't matter because there are no mechanical aspects to this inverter, such as fans or other cooling type of systems, no fluids in it that will be upset by weird orientations. It really doesn't matter to our unit whatsoever. It's a very easy unit to mount. And as you can see, Chris was able to get a selfie with himself next to the Fronius unit in his garage. So that was what replaced that 6 unit in Chris's home garage. So this is what really we wanted to talk about this morning is some success we've had at re-energizing projects. This is a great example. This is one of the first ones that we did a few years ago. And what you're seeing in the top left corner, it's a Satcon Solstice. This, by the way, was the Solyndra building in Fremont, California. So everyone is familiar with Solyndra. They were the poster child for the troubled solar industry. 6 or 8 years ago. I think we've certainly turned a corner here, and this is kind of a nice testimonial to where it's come. So they still had their panels. You can see a few of them off in the distance on their roof, and the Satcon inverters had failed. So they did a runoff with the ProHarvest and an advanced energy unit, and actually got about 8% more production out of the ProHarvest unit than they did with the AE. It was a TL string inverter, so they were able to make an easy decision. What you see there is on the lower picture, you see the 3 inverters with the splice box in sets. There's 1, 2, 3, 4, 5, 6, 7 sets, I believe you can see. And this is actually where the Satcon combiner boxes were. So this is really pretty important for a couple reasons. Number one, you can see there's no mounting restriction whatsoever. We have them vertically, we have them in direct sunlight, no issues whatsoever there. The DC wire connected directly to the units, so there are a couple jumpers. I believe they had to make jumpers for them, MC4, but really very limited DC runs. And then you're coming off with 1 AC run, and you can see it along the bottom. It's all sealed off. You don't even need conduit back down to the load center. So it just is a really clean approach. So again, with those big central inverters, we were able to open up their lobby again and get everything up on the roof where it's within 1 foot of the array as well, which is a nice, fire protection scheme, and really did the trick for them. So not to keep hitting people over the head with this, but the reason that inverters fail is because of fans, because of air filters clogging, maintenance. They're in harsh environments. It's coastal, there's corrosion. You know, these things are in the deserts. You know, you guys know where these are installed. You're installers, so it's really challenging. And if you look at the, you know, inverter companies that have been around, you know, I work for 3 of these companies. You know, if you consider Retrofit a company, a spinoff of Advanced Energy, but you know, essentially PV powered. Solyndra is the unit that you see on the top left. That was a bipolar inverter. The TL, the AETL, was a derivative of that red Retrofit with just another junction box added underneath it, and then the, you know, the SATCON units, which we all know about SATCON. So, you know, great companies, good track records, industry leaders, no longer around. So the trouble really that your customers are having right now is getting easy replacements for these. And you know, what we have been demonstrating is it's a very easy interface with the ProHarvest. I mentioned earlier, you know, the single board with all of the systems incorporated into the design. You know, with these legacy units, what you saw was, you know, them having to add, you know, AC/DC conversion, AFCI communications, all that stuff had to be added on as the requirements of the NEC requirements migrated. So the nice thing is, again, everything that you get from ProHarvest is designed to interact and work with each other. So you know, it's we had no unprotected electronics, no isolated systems. It's all integrated into itself. Bear with me here as I go through this. I forgot that was in there. So this again is the it's Solyndra. Seagate owns the building now, so it's in Fremont. It's right where I think the 880 comes in. It's just there a couple weeks ago. I think that's the road. Anyway, so you can see the runoff in the bottom. You know, that was the Advanced Energy unit. You see our ProHarvest unit. You know, almost 7% more power. By the way, ProHarvest and HighQ are the identical inverters. There's no difference. ProHarvest is just the brand name that we incorporated when we took the technology over to OutBack Alpha. So any opportunities that you guys have, or any replacements that you might need, if there's issues, you know, we can certainly help. And the nice thing is everything is retrofittable. Even the new units will fit in where the old ones did. So yeah, it was really good success. You know, they even used a you know, Fluke data logger, which, you know, people have had troubles with before, but you know, we seem to be able to communicate, no worries with them, and that worked out really well. Again, this is a picture of where the units were mounted. That was where SATCON had their junction boxes and or combiner boxes, and we were able to put the inverters right there. They didn't have to create any new type of mounting scheme or really change much at all on the roof. In fact, they eliminated a lot of wiring. And if you look at that picture on the right, that's the profile, so you can get an idea of how thin and low profile the units are. In fact, one of the things I really love doing when I do live presentations is I'll walk in with an inverter. They're so light and easy to fit. I can actually fit one in my take-on luggage on the plane. Believe it or not, TSA has never given me a problem with it, and I'm able to walk in, and it's a pretty powerful thing when you can bring your technology in front of people, and it's very impactful. I don't know too many other inverter manufacturers that have that same capacity. These are a couple other examples of retrofits that we did. This was one that we had another, you know, removing SATCON, not to keep picking on them, but you know, they're not around anyway. So this was in Newark. This was Central High School, downtown Newark. We were able to go in, remove the inverters from, you know, the outside, which, you know, they had to be fenced in and protected, everything else. We put them up on the roof, took care of the problem, eliminated a ton of wiring. Very successful installation with that. Here's what the roof looked like. This is actually, yeah, this is the high school. So we were able to get the inverters, you can see on the right next to the panels themselves, just clipped in with the MC4 connectors and ran the AC down. So it was a really good fit for you know, what they're looking to do. This was a little racking system that they built themselves. So what they would do is they put these together on the ground. you know, the 3 inverters, junction box, everything wired. So they just bring them up to the roof, put a rec next to the array. You know, they were essentially flush with the, you know, with panels themselves. So they were within, you know, 1 foot of the array. So, and met the rapid shutdown requirements for the new 1 foot rule. And all of the, you know, MC4 connectors just were clipped in, and they were really very happy with the installation. Here's a couple other installation examples that I just wanted to run by you guys. I think we're doing pretty good on time, so I'll just keep going here. This was a roof that we did in New Bedford, Massachusetts, Gentleman's Warehouse. I think that's a national chain. The Joseph Abood Suit Factory. This was in New Bedford. So this is about 1.8 megawatts roof. And again, you can see how they've got them, you know, mounted directly in the sun. Junction box, they're coming out with the AC connection into that conduit, and then it's just, you know, beautiful conduit run down to the housing. So this was a really nice, clean application. Talked about, you know, 1 foot rule. So, you know, ProHarvest, we really, you know, like to encourage people to mount them, you know, underneath the modules, next to the modules. You know, it gives them a lot of flexibility. Everything, again, is terminated, so you just kind of clip it in there. You know, you can see some of the other folks need, you know, space. They're, you know, having to mount spring inverters on the ground because of the weight. You need a couple guys to sometimes, you know, carry them up to the roof. These can be done by a single person. So some of the applications we get into are really, you never want to go up there again. In the case of this waste treatment facility in Fall River, Mass, that was certainly the situation. They had no access to this roof whatsoever, no ladder, no hatch, really nasty environment. They're doing like metal scrap recycling. And the way we got up there was with a crane. So they really needed to have something that they could just set and forget and operate. What they ended up doing was group in the inverters. You can see in this little left photo where those snowbanks are. That's actually where the inverters are. And I think I have a little bit better picture. But again, you know, with the junction boxes, the splice box, I should say, right next to them, very similar setup to what we saw on that Martignetti roof. But this was a really a good example of, you know, roofs that you never want to have. This is the drone shot of it. So actually, where the inverters are is kind of in that central area. There's a bank of inverters, but, you know, really these guys never wanted to have to go up there again doing maintenance on them. So this was really a really great solution for them. They have had a couple of inverters go down. This was built about 6 or 7 years ago, and but, you know, because they're only losing 8 kW, they do an annual maintenance anyway. So they just incorporate it into that if they need to. And, you know, they're able to send a technician up there with an inverter in his hand. Again, everything is terminated. I've noticed about the 50th time I've mentioned that, but both externally and internally terminated. So you don't need an electrician to make these connections. The same guys that are putting your panels up there can make these connections for you in most jurisdictions. I'm sure, you know, there's a few HJs out there that would probably frown upon that, but the majority, that's you know, they're fine with it. Another application that we really do well with, you know, so again, commercial rooftop, we have the perfect product for a commercial rooftop. Carports as well. You know, carports typically have restrictions in terms of where you mount the inverters. They need protection from, you know, kids, you know, doing, you know, what kids do. So, you know, with our you know, ProHarvest inverter, we can mount them, you know, up out of the way on those stanchions. That steel actually helps us in terms of heat sink, so it actually makes the inverters operate even more efficiently. Everything is up and out of the way. There's a dial on the side of the inverter, so you can see its operation. If it's, you know, running and it's got a green light, you know, you're good. If it's got a red light, you know, you need to take a look at it. So it's a really space efficient, safe, and rapid shutdown compliant, again, because you're, you know, within the 1 foot of the carport there. So it's a really good fit for us. And we've got a number of installations around the country in carports. and a lot of them are publicly accessible. So, if there's interest, I would encourage you to reach out and, just let us know where you are, and we can give you a couple references that you can drive by in your lunchtime and take a look at how they mount them. It's a pretty powerful tool. This is another carport that we did in Ontario, California. As you can see, the inverters are mounted like right directly underneath those translucent panels. It's very easy to wire. Junction box coming in, load panel right there, boom. This was a very successful project. This Bourne site, so Bourne, Massachusetts is located directly above Cape Cod. So the Cape Cod Canal essentially separates Cape Cod from the first town is Bourne. The reason I mention this is the load center for Cape, or the generating station for Cape Cod is actually north of Bourne. So all of the energy going to the Cape essentially passes, through this array. And what we were finding is we were having inverters blowing pretty consistently. And it was obviously a big concern. One of the features that we have in the inverter itself is an oscilloscope. So it's not activated all the time, but we can definitely set it up to take a range of shots on what's happening in the system. And what we found out in this case was that the utility was doing a power factor correction every morning at 9 a.m. and sending a large current through the system. And this was the first thing it hit. There was no load center in between it. This was just going right into the array. And it was, those first inverters that were getting that energy were just not able to handle it. So we did a couple things. We encouraged the customer to go back and work with utility, put some type of a protection on there. But we also changed the overcurrent circuit in the units themselves to be able to handle a larger current. So it was a good learning curve for us. This took about 3 weeks to resolve and a lot of effort. But at the end of the day, we were able to, really prove the functionality of the units, just in terms of the built-in feature, that oscilloscope, but also we were able to get that board changed and reapproved through UL in a very timely way, and that resolved the problem. So this was 1.3 megawatts ground mount. Great application for ground mount if you're in a brownfield. You can't penetrate the cap. You don't need to with these units. You can just essentially mount right on the racking. Another great application for us is trackers. So we do a lot with trackers. We work with a couple OEMs on them. Again, another hidden feature in the units is a accelerometer in these, so they can actually tell position of the unit, which, the majority of solar applications and installations, you're not going to see the inverter moving, so it's a bit of a kind of a funny feature. But in the case of a tracker, it can be pretty interesting because you can, kind of correlate data, positioning. If you're seeing something, odd in the array itself, you can figure out where the where the units are. So kind of a nice feature. And again, this was one where they couldn't put anything in the mud. All the wiring had to be above, and the fact that we're just coming back with the single AC run, it makes it a really really elegant solution for this tracker application. So again, this is kind of a summary of what we've been talking about. Really, the units right now are designed for North America, so it's a 60 hertz design, designed in Santa Clara, California, for the U.S. market. We are working on a 50 hertz version for Europe. You'll probably see that about this time next year. We see some opportunities there. So, designed for North America, commercial market, 3-phase. There's no mounting restrictions. There are no AC disconnects required and no DC disconnects required, provided they are mounted, within the array restrictions per your NEC code. Sometimes you will get, again, an AHJ that doesn't appreciate the tap rule or the 1 foot rule, or, he'll be insistent. Sometimes he'll require you to put an AC disconnect on there. Most of the times they don't, and we have not had any experience with them requiring DC disconnects. The AC wiring, it's expensive, but it's not as expensive as DC wiring. So really, we're looking at cost reduction for you guys, the installers. We're looking at time reduction, installation reduction. Just really, we want to, be the easy, set it and, forget it solution for inverters. All the grounding is provided through the AC whip cable, so no external, ring is needed. Actually, a lot of our customers will ground. There's actually a grounding hole on the side of the ProHarvest inverter that they'll use to ground their system. So you can actually ground through the inverters themselves. Talked about rapid shutdown, meaning its requirements with no additional hardware or labor. And again, this has to do with the orientation of the unit, it being mounted within 1 foot. Design is very straightforward. We saw that one line. There's not much to it. Labor. This is really where we feel our value is exemplified. It's cost of ownership. So we're not the cheapest inverter on the market. We're not going to be, the 9-8 cent Chinese inverter. We're more than that. But the overall cost of ownership, once you take the install cost in, we've seen installers, and we've got papers that we can point to demonstrating this, but 5 to 8 cents per watt cost savings in labor, which is really time, and material, which is really DC wiring. So, once you take that into effect, we're actually more competitive. But then if you take into account the uptime and, what happens when a unit goes down, one of our units goes down, you're losing 8K. One of their units goes down, you're losing 60K. So it's, it's definitely a scale. Neither situation is ideal, but one certainly creates more, critical mass than the other. And as we discussed, our technicians typically can go in and fix the units remotely. If not, you should have a new one within 48 hours. So it really eliminates downtime. Therefore, there's really no O&M to it. The faults are reset remotely. Inverters are replaced, 5 minutes to, make connections with the units themselves. We have our fault protection is integrated, so there's no additional hardware. That's all incorporated, and we talked about the gateway, so the monitoring is included as well. So that's about what I had for my slides. I think I'm a little bit quicker than I thought. Hopefully that's good for those of you like me who are on East Coast time and this is the middle of your lunch. But I would really welcome any questions, and feel free to reach out to me as well. You see my contact information there. But I have some time for questions if there are any.
All right, thanks, Joe. We'll go ahead and kick off our Q&A session here. We've got a few good questions, and feel free to keep sending them in since we do have some extra time. All right, we'll start with our first question here. You said that it is rapid shutdown compliant, but is it compliant with the 2019 module level requirements?
Right, so those are two separate things. So rapid shutdown really has to do, it's the 1 foot rule. In 2017, it went to 10. In 2019, it went to 1 foot. So again, that's really orientation of where you mount the inverter, and we give you limitless, possibilities for how you do that. The other thing that was enacted in 2019 was the module level shutdown, and that is really a, it was put in, I should say, it was put into effect in 2017 as well, but it wasn't implemented until January 1st of this year. Because nobody had a solution. The module manufacturers didn't have a solution. There are some third-party companies like Tygo and INS, kind of expensive, but did the trick. So currently, we have tested with third-party suppliers for module level shutdown. So we do have a solution that's applicable. Keep in mind that right now, California is not implementing the module level shutdown until January 1st of 2020. So any projects that you guys are working on this year, you don't have to worry about that. And then we work with, with industry, partners and leaders and verticals, and clearly one is the panel manufacturers. And we've gotten indications from them that the new higher density panels that will be introduced here later this year are going to actually incorporate this feature into them with 2 different junction boxes. So, you know, that should take care of the problem. And quite frankly, that's really who should be addressing the module level shutdown. It should come from the module manufacturer, from, in my opinion, and not the inverter manufacturer. There are a couple inverter manufacturers that do have that do claim that they have the module level shutdown capabilities, and they can prove it out during their witness test. But what will happen after that is that will cause more times out of not false tripping on their AFCI. So what you end up seeing happen is they turn that feature off. People don't like to talk about it, but that's, you know, that is the real world situation. So clearly that's not a good solution either. So again, currently third-party companies, Tygo, INS, the Fire Raptor, you know, we can work with. Moving forward, we expect to see the module companies coming up with their own solution, and you really need to be cognizant of, you know, false tripping, nuisance tripping issues that, you know, other inverter manufacturers are experiencing because they are trying to roll this feature into their existing box.